we've set up here an app that that you can access by just clicking on this link. And if I click on that first sheet, it's going to then drill into this cradle to grave analysis that we've set up as for demonstration purposes. You can see here you've got a calendar that you can select various dates, but what I want to focus on now is these current mini KPIs that we've set up to show what the current status is for the 13th of April, which is the date where this is the latest data is current to. So we've got about 10,000 rows of data into the system based on the 4th of Jan to the 13th of April. And overall, over here you've got an overall status that does show you from the 4th of Jan to the 13th of April. And so here we've just worked through what the current or what the tonnage moved last week was, and whether this week versus last week. You've got a bit of an indication here, up or down arrows, coloured green or red. What the current holding bay tonnage is, it's about 530 tonnes, and we know on average the holding bay tonnage is about 530, so we're about 10% full based on that reading, and gives it also an indication of the current chainage, domain, and Regos trucks that are in use. If I look at my overall status here, I've got a bit of an idea about the overall tonnage moved to date, and what split's been going to containment. So here's a bit of a gauge. It's showing you just about 24%, or sorry, 22% has been going to containment, and giving you the actual tonnage that have gone to landfill and containment in this date range. We're also looking at bringing in potentially the sample data. So once the sample data comes in, we've got some PFAS levels, and we can do some analysis on that here as well. And that's just showing you what the average is to date. If I just scroll down a little bit here, I just want to focus here on a visualization we've created that actually could show the tonnage flow from bore to destination, so from cradle to grave, through the various key aspects of the process, which could be through the chainage, through the holding bays, and ultimately to landfill or containment. And what we can do, we can just hover over any of those elements, and it gives us a bit of a clearer picture in terms of where the flow has gone from. So you can see here, for example, everything that's gone to containment thus far has gone through five holding bays, which are highlighted here, and various chainages. And of course, at the moment, we've just got TBM1, so everything's come from TBM1. So this also gives you a quick view about how things are flowing through the system, and whether potentially there could be any anomalies that we need to focus on a bit further. Like I mentioned, we have a calendar function here where we can select certain date ranges. So I'm just going to select from the start to the 9th, which is sort of the first week of operation. So overall here, the overall status does change, of course, because now we're just focusing on the 4th to the 9th of Jan. It gives us a view for that week, what sort of tonnage there was. So you can see here the split is slightly higher than it was for the overall period, and it gives you the actual tonnages there. If I scroll down here, you can see here that the process flow diagram has actually changed a bit just to show us what's happening in that first week. Up here you can actually see I've filtered on those dates, so it's showing me these are the dates now I'm filtering on in my analysis. So at any point in time you can always see the context of what you're looking at through the filtering blocks up here. So I'm just now going to remove that filter. So what I'm now looking at, of course, now is the total status. Of course, we're looking at all the data, so it's from 4th of Jan to the 13th of April. And what I want to do now is just highlight everything that's gone to containment. So once I select that, everything is updated. I can see here, of course, everything's moved only to containment. And what I want to do now is look at the trips involved and everything that's gone to containment. So if I click on the trip matrix, we've set up a bit of a heat map view of what's happening via the various chainages through the various vehicles that have or trucks that have moved the soil. And you can see here that the chainage 53120 has got the highest density in particular in the system. So if I look at any of these, I can actually see the various tonnage, net weight, regos, chainage. So I've got these tooltips that can give me some idea of what's happening. And if I click on any, so I'm now looking at vehicle 18, if I click on that, that will then summarize or focus in on that vehicle on my pivot chart. I can look here, it's by a transaction number. So if I just break that down, I can see the individual transactions that have made up that vehicle's trips that have gone to containment. And I can have a look down here, and might say, well, I want to look at this one here because that's a little bit lower than previous. So if I click on that specific transaction number, select OK, and I go to my next tab, I'm actually now into the most granular detail that I've got. So this is the detail of that particular trip that the truck has made, giving me all the data that's relevant to that trip. If I quickly just show you up here, so you've always got here a context of what you're looking at. So you can actually see now I'm looking at transaction 4398. That's for vehicle EPH 18. It's coming from this chainage. So of course vehicle 18 will go through will collect soil from various chainages. In particular, I'm just looking at this this chainage, and it's going to the destination, the containment cell. So you always got the context of what you're looking at through this filter breadcrumb. And of course you can always then deselect all selections, and what you're left with then would be 10,000 rows. Currently we've got 10,000 rows of data, so you have all the data here that you can analyze. But of course, looking at 10,000 rows of data is quite meaningless unless you can do these drill down concepts. So what I want to do now is just move on to our second sheet that we have for our analysis, and that looks at the holding bays. If I just now select, say, the 5th of January, I can see here at the start it's telling us, yeah, holding bay 1 was just filling, and of course all these other holding bay transaction IDs or holding bay IDs were of course empty because we're just starting the proceedings. But selecting any other date, say the 26th of the 1st, will give me here a status of what was happening on the 26th of January, where holding bay 1 was being emptied and was going to containment. So the rest were full, and holding bay 16 or holding bay ID 16 was filling, and of course the rest were empty because they weren't part of the analysis at that time. We've also here got a mini dashboard report where you can actually select various holding bays. So holding bay 7 will give you here now an idea about what was happening in holding bay 7. The chainage, what environmental domain, when it started filling, finished filling and emptying, and the destination. But you can also then do a selection of 8 and 9 to give you a variety of different holding bays you want to have that summarized analysis from. So now what I want to show is a different process flow representation of what is happening. So here we have the flow from the TBNs all the way through the various stations, as we call them, all the way to the disposal site. And each one of these stations we can actually just hover over to see what the current status is. So here, of course, at bin 2 we're seeing that on the 13th of April, the throughput we are seeing is 5,634 tonnes. We've had about 127 trips, and we're purchasing through, or we're going through the current chainage of that 53235 chainage number. So like I said, each one of these nodes can be a different representation. So here we've got throughput that's 2341 and so forth. So it's just a different representation of the information that's being fed through the system. So if I click on the chainage status, we have a different view here. So this is the view of what's happening with the test results coming through the various chainage parts. So here all these test results have been finished. Here we're looking for test results that in that murky grey that are coming through, and the ones in red are still in process. So you can select any one of these changes, and then what will happen here telling you that it's in post-testing phase, and this is a representation of what's happening there. If I deselect that little chainage, I can actually get an overview of what's happened for the day. I can see here that I've got the tonnage that's gone through the containment cell, what's gone through landfill, and then there's a differential here in the reconciliation of about 65 tonne. So you can actually represent what's happening in various ways. So the next sheet I want to show you is a view of some of the test results. So once again, we're doing a lot of testing, and if the test results can come into the dashboard environment, we can also look to visualize that in certain ways. So this is a view of the various, once again, the various results from the test results, showing the different types of PFAS that's occurring. And you can actually select each one of these chainage amounts to see what type of PFAS representation is happening there. So it looks like in this particular chainage, you've got a distribution of this type of result. If I want to look at some individual results, a bit of a density plot to see where the major things are happening, you can represent that as a density plot. And if I just select on PFOS here, you can actually see here that down here is a higher concentration of those elements in the sampling data. So whilst it's not part of the end-to-end spoil management system in terms of tonnage, you can actually also bring in a lot of this this analytical data that's coming from the sampling to actually create a full rounded story of what's happening. And this can be represented in a number of ways, just to actually visualize what's happening.